In the great silent chamber, where time and secrets lie for years, new discoveries have broken the foundations of our understanding. A marvel of human intelligence, the James Webb telescope has pierced the sky to reveal 6 ancient galaxies whose masses defy the universe's standard model. This revelation sent shock waves through the scientific community and deeply re-examined the origin and evolution of the universe. Experts hoped that these structures could not create others, but now the telescope has found another galaxy, older and the same size. Therefore, scientists must admit that they do not know enough physics to explain how the universe looked in the past. What does this mean for the big picture? Does this mean the Big Bang theory has arrived? And if so, how did the universe come about? When the James Webb telescope flies into space on December 25, 2021, it has a deeper mission: to change our understanding of the universe. Less than 3 years after its famous launch from the Guyana Space Center, it is clear that the $10 billion instrument is fulfilling its mission with flying colors. Designed for infrared astronomy, the Internet can detect the temperature of bees on the Moon from Earth. In the process, highly sensitive infrared optics have added the first supermassive black hole, the world's morning star and the oldest known galaxies to star maps. Therefore, each new discovery of the Webb is a new potential for knowledge. But sometimes this knowledge also includes the fact that everything we thought we knew about the processes of creation in the first world was wrong. That it was only at the beginning of last year that the experts found out. Meanwhile, the James Webb telescope discovered that the first 6 galaxies existed 500 to 700 million years after the Big Bang, which should never have existed. According to the universe, these star clusters are very small and have low mass. However, the world may not be interested in our international students. The mass of the newly discovered galaxies is about the same as the mass of our Milky Way galaxy. Based on these data, the 6 structures have more than 10 billion solar masses. One of them might break 100 billion solar mass points. Given this, senior astronomers at the University of Technology in Melbourne and Pennsylvania State University thought at first that they were wrong. But despite all the checks and operations, the data set was still correct. Why is this such a big problem? The mere existence of these supermassive galaxies would change almost all current planetary models. These models show that the first stars formed 200 to 300 million years after the birth of the universe. They also think that, when these galaxies were discovered, there was not enough common matter to create so many stars in such a short time. However, it is possible that some of these objects are dust-covered black holes. However, the problem of a planet with a thin atmosphere does not go away, because there is much more material in the universe than previously thought. If one of these galaxies is real, it would exceed the limits of our understanding of the universe. The density of matter in the early universe may have been 2 to 5 times higher than our models suggest, or galaxies may have grown in a way we don't fully understand. As befits the most powerful telescope of all time, Webb is a master at outdoing himself. In July 2022, astronomers will be proud to have discovered the first known galaxy. In detail, Glass Z13 already existed 300 million years after the Big Bang. Now Webb has found a new galactic record holder. Scientists led by Stefano Carniani from the Scuola Normale Superiore in Pisa have discovered a group of stars that appeared 290 million years after the creation of the universe. Given the scientific name JWST Z14-0, the galaxy was there when the first stars were born. Although this bomb was deployed in early June, the formation appeared in the spring of 2023 in images taken by the Near-Infrared Camera, NIRCam. In the corresponding data, the experts found clear signs of redshift beyond Z=14. In order to understand why the Earth is so broken, we must first take a short trip into a redshifting world. The absorption lines in the spectrum of different galaxies are different, and the absorption lines of distant galaxies are even more variable. However, the reason for the redshift is not the relative motion of the galaxy compared to the observer, but the expansion of space. In astronomy, redshift is often expressed using a zero-dimensional z-value. For example, if the redshift is z=1, the universe was only half its current size at the time of the light emission. However, pure redshift cannot tell how the expansion works. It becomes clear why experts are so confused about the z equals 14 redshift when we consider that the previous record for the galaxy is z equals 13.2. To reveal the true background of the brightest structure, the research team used the James Webb Telescope's Near Inspection Resolution Certificate, NIR spec, and found 14.32%. The so-called Lyman alpha break, whose location indicates the extent of the redshift, leaves no doubt about the existence of this cold star-like world about 290 million years ago. After the Big Bang, however, this is only half of the astronomical truth. The galaxy was probably formed a long time ago. Experts believe it took 100 million years to grow to the sizes seen. However, it is not the record of the early formation time and the distance of the cluster that has most impressed the researchers, but the fact that the galaxy was very bright in the past. According to experts' assessments, the star must already contain hundreds of millions of solar masses. The question then arises, how was it possible? How could a bright, large, and massive galaxy form in less than 300 million years? This mystery is compounded by the mysterious fact that the halo contains bright emission lines of hydrogen and oxygen. It's a surprising discovery, showing that many very interesting generations of stars went through their life cycles before astronomers saw this galaxy. Finally, this unexpected discovery shows that the previous research picture of the early universe, with small and still faint galaxies, is out of date. In fact, scientists hope that this change of mind will be tested again in the near future. The James Webb Telescope may discover many of these impossible early galaxies in the coming years. They say, recent discoveries, among others, are moving scientists away from the Big Bang theory. A quick reminder, this theory states that space, matter and time emerged from a singularity about 13.8 billion years ago. But even if the Big Bang is now considered an astronomical theory, the discovery of the microwave background radiation shows that even the supporters of the theory face some questions that do not have clear answers. This is about how and why. How was something created from nothing 13.8 billion years ago? Can anything be created out of nothing? Is there a strong motive for this, or is it just a coincidence? Stephen Hawking said that time only began with the Big Bang, so nothing or anyone else could have created it. The question of uniform radiation and the density of the universe is no less problematic. No matter what direction or distance we look, on a large scale, the density and distribution of galaxies, nebulae and radiation is the same everywhere. Great philosophers explain this with the rise of the world. Other scholars take this view even more seriously. Depending on the rate of inflation, it can be assumed that this process will only end in some bubble-like region and then last forever. This also means that many subworlds are created in bubbles, each world having its own physical laws. In this situation, a question arises: what if the world does not hold a great image? Moreover, what if there is another world before us? In this case, the Big Bang would be a leap. According to this hypothesis, concepts such as beginning and end are invalid in a global context. What we call the Big Bang is nothing more than a cycle of change. When the world dies, a new world is born. According to this model, the universe, as part of a multidimensional structure, is subject to an endless rhythm of decay and recreation. However, this is not the only explanation. Apart from the Big Bang theory, the most important and controversial theory of origin comes from the world of quantum physics and string theory. Experiments, they say, have shown that the universe and everything in it does not exist. Simply put, what we know as the visible world is a flat hologram projected onto the world. As a result, we and our reality are the product of synthesis. What kind of scene in the next Matrix movie might involve the so-called Kardashev scale? This classification shows the progress of the world in terms of effort. If the universe is type 3 and can use the full power of the entire galaxy, it can create a complete simulation using the so-called Matryoshka brain. Whether we really want to know the truth about our home in this case is a different question. As we grapple with these deep phenomena, the James Webb Telescope continues to peer deeply into the universe, revealing new mysteries every day. The findings challenge our understanding of the world and force us to confront the limitations of our current scientific models. Will the Big Bang Theory meet these challenges, or are we approaching a paradigm shift in the universe? Only time can tell. The truth is, the world is much more complex and wonderful than we thought, and we are only just beginning to understand it.